let's do an example. Gerard wants to rent a canoe for a day trip. He gathers information from 2 places and decides to make a table of values and graph each of these relationships. Big Pine Outfitters, the first company, charges a base fee of $40 and $10 per hour of use. So he has to pay $40 no matter what, and then for every hour he has to pay $10. The other company, Hemlock Bluff Adventure Store, does not charge a base fee, but charges $30 per hour to use the canoe. So Gerard made this table of values, and he goes up to 3 hours. So he has his time, goes from 0 to 3, and then you can see where he calculated, all right, if he goes for 0 hours at Big Pine, it's $40. If he goes for 1 hour, it's $40 plus 10 times 1 for 1 hour, so it's $50. 2 hours would be another $10, so that would be $60. And 3 hours would be another $10, so that would be $70. And then here's the graph for Big Pine. It starts at 40 for 0, and then at 1 it's 50, 2 hours is 60, 3 hours is 70, and then it continues on for more hours. For Hemlock Bluff, it's just $30 per hour. So if you have 0 hours, you pay $0. If it's 1 hour, it's 1 times 30, so it's $30. If it's 2 hours, that would be another 30, so that would be $60. 3 hours would be $90. And then here's the graph of Hemlock Bluff. And you can see those values. What is the cost of each canoe if Gerard cancels his reservation? So if we look at Big Pine, if we cancel the reservation, we still, so I'm going to use BP for Big Pine. If he cancels the reservation, he still has to pay $40. For Hemlock Bluff, if he cancels the reservation, it's $0. Compare the rate of change of cost for Big Pine and for Hemlock Bluff to the cost per hour for each outfitter. So let's go back up here and review how to calculate rate of change. So remember, we have to take 2 points on the graph and make a rate triangle. So now this part going up, oops, it's hard to write on here. This is called the rise, and the horizontal part is called the run. The rise goes from 40 to 60, so that distance is 20. The run goes from 0 to 2, so that distance is 2. So the rate of change for Big Pine, remember it's rise divided by run, that would be 20 divided by 2, and that equals 10. Okay, and now let's do Hemlock Bluff the same way. So we have to go to our chart and we pick, or our graph, I mean, we pick 2 points that we can easily identify. So I can see that this one is easy to identify, and back to the 0. The rise is the part going up. The run is the horizontal part. So the rise here goes from 0 up to 60. That means that the rise is 60. The run goes from 0 to 2. So you say the run is 2. So now what we do to calculate the rate of change is you take the rise divided by the run, and that is 60 divided by 2, which equals 30. All right, so we're comparing the rate of change, that's what we just calculated, with the cost per hour. So if we go back up here, the cost per hour is right here. For this one, the cost per hour was 10, and for Hemlock Bluff, the cost per hour was 30. So the rate of change and the cost per hour are the same. Cost per hour and the rate of change are the same thing. Which graph illustrates a proportional relationship? How do you know? This is called a direct variation. So we need to talk about what's a direct variation. Direct variation means that there is no base fee. So this one here, Hemlock Bluff, this one is called a direct variation. It's not going to fit on here, so I'm just going to short form it. Because it starts at, right here, 0, 0. So there's your clue for the fact that it's a direct variation. There is no base fee. You can also see here at 0, it's 0. That makes it a direct variation. It's important that you remember what is a direct variation. So the one we're going to put down here, we'll just short form that, Hemlock Bluff was a direct variation. Which graph has an initial value other than 0? Initial value means the value at the start. When your independent variable is 0. So the one that has an initial value other than 0 at time 0 is this guy. So that means if this is a 0 and this is not a 0, this one is an example of what's called, let's see, I can't make it right. This is a partial variation. On the graph, you can see that a partial variation doesn't start at 0, 0. So the graph that is a partial variation is the one that is Big Pine. Which outfitter company should Gerard choose if he estimates he will canoe for 0.5 of an hour? So we could go up and use our graph and see how much is 0.5 of an hour, but we have a way of figuring out the cost. We know that Big Pine is $40 per hour. So I'm just going to say times the number. No, it isn't. It's $40 plus the flat fee. I made a mistake there. It's $40 plus $10 times the number of hours, because that's how we figured it out in the chart at the top. So if we use it for 0.5 of an hour, we're going to have 40 plus 10 times 0.5, and that is $45. If he goes for 1.5 hours, it'll be 40 plus 10 times 1.5. That would be $55. And if it's 2.5 hours, it's 40 plus 10 times 2.5, and that would be $65. For Hemlock Bluff, all we have to do to figure out the cost of it is to take the number of hours and multiply by 30. So 0.5 times 30 is equal to 15. 1.5 times 30 is equal to 45. 2.5 times 30 is equal to, I have to check, I think it's 75. It is 75. Just to explain how we determined our answers, well, by me showing those calculations, that's how you explain how you determined your answers. That's how you show your work. Let's go to the next page. Now we're going to write an equation to model the cost for each outfitter. Let C represent the cost in dollars and H represent the time in hours. So we already have the C equals here, and we know that for Big Pine, we had 40 plus, and we did 10 times the number of hours. So we can write that like this. We don't have to use the multiply sign. We can just write 10 times H. That is the equation. For Hemlock Bluff, it's just $30 times the number of hours. That's the equation. Now, I want you to notice here again, remember, this guy here, this one is partial. I don't know if it's going to fit. No, it doesn't fit on here. Okay, I got to erase that. So the one that has the two parts, the 40 plus something per hour, is a partial variation. The one that just has the 30 times the variable is the direct variation. If Big Pine Outfitters decided to change its base fee to $50 and charge $10 per hour, what effect would this have on the graph? So remember, I'll just kind of make a sketch of what the original one was. So this was Big Pine, and it went like that. So if I change the base fee is now higher, but I still charge $10 per hour. That means that my rate of change, which is the slant of the line, is going to stay the same, but the $50 per hour, that's where my line starts. That's my initial value. So my line is going to go like that. It's going to be parallel to the original, but it's going to start up $10 higher. Now we have to make the equation to go with that. All right, so the cost is the flat rate changed, so it's 50 plus it's still $10 per hour. So there is our equation to model that one. If Hemlock Bluff decided to change its hourly rate to $40, what effect would this have on the graph? So here's my original graph. It went like this. But now if I'm going to charge more, got to think about when we had the distance times graphs. If you went faster, your line was steeper. This is the same idea. If you charge more per hour, your line is going to be a steeper line. It's still a straight line, it's just steeper. And it still starts at 0 because it's still a direct variation. The equation for this is now $40 per hour. So we write 40H. For Big Pine Outfitters, how are the pattern and the table of values, the description, and the equation related? So here we have it all together. Big Pine Outfitters charges a base fee of $40, and we're going back to the original, and it's $10 per hour of use. So we have the table of values, there's the equation, and here's the graph. So that's how everything is related. You can see the initial value there is 40. It has it right there. It has it right there. And it says that the base fee is 40. The $10 per hour, remember we figured that out over here when we figured out the slope. This was, or not slope, the rate of change. This was 20 over 2. 20 divided by 2 is 10. This is a 10. And if you did your first differences here, if you were to subtract all of these, you would see that your first differences are all 10. And I'm going to go up here and circle maybe this. So there's the rate, there's the rate, there's the rate, and there's the rate right there. Now we'll look at Hemlock Bluff and see how they are all related. So first, we'll look at it's $30 per hour. So you can see here, it's 30 per hour. This is going up by 30 each time. And all we have in the equation is the 30 per hour. If we were to figure out the rate of change, this would be 60 divided by 2, and 60 divided by 2 is 30. There is no initial value. There's nothing that's added on here. So this is 0, makes it a direct. There's nothing added on here, and this starts at 0, 0. That's how it's all related.